So moving on to question 9 now. So let's read it. Well, let's take a look first. So we have a nice little picture here of an array, a three-dimensional array of cylinders. What that just means is they're going to the left, they're going backwards, and they're going up, of what looks like a cylinder. But this is question B. So let's look at question A. It's probably a basic calculation on area or volume. Let's see. Yeah, it's volume. A can in the shape of a cylinder. Okay, so straight away once we see the word cylinder, we're heading to the volume section of our tables. Okay, the area and volume section of our tables, which is page 10 and 11. Okay, and on page 10 we have the cylinder. Okay, so we'll continue on to see which formula, what particularly they're looking for, but they are giving us a model here now. They're telling us the radius and they're telling us the height. So in order to get partial credit and everything, I'm suggesting we're going to draw that with the values included on our diagram. Okay, so we have a height of 10 centimeters. So it just makes it far less likely we're going to mix up our radius and our height, which can happen otherwise because they're both in centimeters if we draw them onto the diagram. And we have a radius equal to 3.6 centimeters. It's okay to offset your radius value from your arrow. Okay, don't feel you have to squeeze it in here. Work out the volume of the can. Okay, so it's the volume formula, so I'm going to write down this lower one that my finger's on here. So I'll write down the formula. V is equal to pi r squared. Well, we recognize that as the area of a circle, so that's the base, and then times the height. So it's exactly the same as the formula for a prism, really, where you've got the base of the prism and then times the height. So it makes sense. And give your answer correct to 2 decimal places. Okay, let's go ahead and bring up the calculator. We'll calculate that here. Sorry, I'm going to just I'll stay on here. I'm going to do the substitution. The substitution gets you up to mid partial credit. So that's an important step in case anything goes wrong later. So I'm going to have times 3.6 squared. So I'm writing down what I'm about to put in my calculator, times 10. Okay, and we'll put the centimeters, we'll put the units in later. Okay, so that's got to go to my calculator. It's all one line, there's no fraction. So I'll start off with my pi value from the calculator there, times, now I put that in a bracket but it doesn't need to be, truth be told, it's just a single number, 3.6 squared, so I'll leave out that there, and times 10. Okay, have a close look at it, make sure that everything is right the way we want it, and hit equals. Now hit equals will give me a exact value, which I'm going to write down out of good practice, even though it's not the answer we're looking for now, and then I'll do approximate, which on nearly every Casio calculator, shift equals will work. You can go digging into submenus or using the SD button, but shift equals will work on all of them. Equals 407, 2 decimal places. I'm looking at the here at the 0.15, so it's very clear that it stays at 0.15 centimeters cubed. Of course, it's a volume. Okay, we'll put the calculator away for now. We'll continue on with our question. So I'll just check here, give your answer in centimeters cubed, yes, and 407.15. Does it make sense? Yeah, well, a liter is 1,000. So in that sense, it makes sense. Okay. So the cans can be arranged inside some dead box. "24 of these cans can be packed into a closed rectangular box." Okay, so the top and bottom of the box, they might be asking us a net question on the box and later on. And it's important that it's closed so that all faces are present. Now it's important to distinguish between the context and then the question itself, because often we'll get the context from looking at the picture, which I think in this case is also true, only we're being told there's a box around the outside. So the cans can be arranged inside the box as follows. And what I'm doing here is I'm going as you get further on, and as you get a question that should take 15 minutes, there's more problem solving involved, so it's important we go through the problem solving steps, which is what? Understand the problem, plan your answer, execute your answer, and then look back to see did you put in all the units, and is there other learning, and what's the style of question exam papers now. You mightn't think it in June, but you're always learning maths, and in an exam you're learning maths, and that's what the look back is all about too. Okay, the can be arranged inside blah blah blah. Write down the height, length and width of the smallest rectangular box that will be needed for these 24 cans. Now they're not asking you to rearrange this, and one is already done for you. They're asking you to look at all these things. Okay, so the important thing here is the radius is 3.6, means the diameter equals double that, which is 7.2 centimeters. Okay, so it's important we keep track of our variables. So there's d equals 7.2. Now in terms of the length, each one of these has a diameter, so it's 4d. Okay, so let's just get that calculated right now. Indeed, it's 8 radii as well. If I wanted to go with 8 times 3.6, I could have done. So it's a natural number by a terminating decimal, which will always give a terminating decimal. 28.8. And just to be sure, I'd like to also do 4, just to be sure that I'm right in every way. 4 times 7.2, just to see does it give me the same answer. Oh, made the same mistake again, not do shift equals. 28.8. Okay, perfect. And so it's in centimeters. Now my width is 3 times 7.2. Let's just go in here and turn the 4 into a 3. And let's do shift equals this time. It'll end with 0.6. 21.6. And then the height is 2 times the height, which is 20, which won't need a calculator. Okay, and we can write them in here. 20 centimeters. Sorry about the background noise. My bean to cup has decided to clean itself. And the width. And that was nice, because it's always nice to have confirmed you got one right and that you're on the right track. It's reassuring. Now watch out for here now. There are no units on that, so 21.6 centimeters, and I put centimeters here, and they put the centimeters indicating it's necessary. Now work out the volume of the box. So the volume of the box, it's not in here anywhere. Okay, the volume is equal to, so I have width, length and height. It doesn't matter really what way they go. Width by length by height will be the model formula for us, and we will multiply 20 by 28.8 by 21.6. Now the units will be centimeters squared, cubed of course, and we leave it at that unless they ask us to change. So 20 by 28.8 by 21.6 equals 12441.6. centimeters cubed. Now if we move 3 decimal places, which it's equal to 12 point, it's amazing they didn't ask us to round or anything, and so we're going to give the exact answer because it is terminating, so it doesn't go on forever. So 12.4416 liters. because 1 liter is equal to 1,000 centimeters squared. So moving decimal place 3 places, and you don't have to be asked to do this for convenience. So either of those answers would be correct. Okay. We drive on. So work out the percentage of the volume of this box that is taken up by the 24 cans. So we know the total volume is here, either one of them. Sorry, just off picture there. And we know the volume of 1 can is 407.15. And we know that there are 4 by 3 by 2 cans. Okay, just looking at the picture we can see that. I'll kill the calculator for a second. Okay, so until we need it again. So 4 by 3 by 2, 4 3s is 12 and 2 12s is 24 cans. So now this is where the problem solving comes in. There's a lot going on here now, and I need to organize my thoughts. So I do understand the problem, but I am going to have to plan and mathematize it. Okay. So first, work out the percentage of the volume box that is taken up. Well, that's good. So in terms of percentage, you want the actual value taken up divided by the volume of the box. So we're going to have 24 multiplied by 407.15. Now that's a quantity we don't actually need at any stage to express. So it's okay just to leave it like this. Divided by the volume of the box, which is down here. And if I'm going in centimeters cubed here, well, that's cans. This is centimeters cubed. I want centimeters cubed here, which is 12441.6. And then they said they wanted it as a percentage, so I'm just going to bring in this, which you do not put the percent in your calculator, you'll be in right trouble because it won't do anything. It'll be multiplying by 1. So let's hop this into the calculator. Oh, I don't have the calculator. Casio. Hold your horses now. I want to get my calculator up without going into my operating system, and well, where's my shortcut? Buried somewhere. Hold on. Okay, hold on now. We're going to have to dig this out from Casio, and I'll put in okay, let's get this onto my taskbar for quick pin to start. Fine. And I'm going to also pin it more, pin to taskbar. Excuse me. Okay. Now, should be coming back a bit quicker in future. So we essentially want to be using a fraction bar because we have a fraction there, and you want to get that in early. It makes compound fractions very simple. 24 multiplied by 407.15. Have it here. Oh, I pushed I instead of 0.15. Okay, now I can run along here with multiply by 100 instead of putting it over separate, just it's all in one, because of the fact that division and multiplication are at the same level in the order of operations, and it doesn't make any difference which you do first. Divided by my 12441.6. I'm being tested here in attention to detail, really. 441.6. That's a very big challenge, I think, and an unnecessary challenge. I don't think that was fair. Okay, and I'll just do shift equals because we want to go straight to decimal. By the way, it won't terminate because there's a 0.6 here, which has a fact which there's a 3 involved in, so I'm not expecting it to terminate. And now I want to get back to the context, so it's a percentage to 1 decimal place, it's saying here. Okay, so I'm writing down, I'm going to do this on the fly, so is approximately equal to 78, and I'll leave the 5 where it is because that 3 here doesn't take it up. Okay, 78.5%. Excellent. Does that make sense? Do you want most of your box filled with beans? Yes, you do, but there's nothing you can do about that space. That's geometry. Geometry is geometry, you can't do anything about it. Interestingly enough, at the top level of developments in maths, there was a question just like this for how many spheres can be packed into something. You can look it up, I'll share it with you somewhere else. So questions like this can be at the forefront of maths. It's very interesting. Okay, there are a number of different ways of arranging the 24 cans so that they can be packed into a rectangular box. So yeah, so they're getting into number theory now, and the fact that we have 4 by 3 by 2 could have been 2 by 6 by 4. We can shuffle. Basically what we want to do is look at the prime factors of 24, but let's do that now. Let's say we know 24 is the kind of the volume, okay, and it's all about the prime factors of 24 now in terms of what are our options. So you have 2, so 24 equals 2 by 2, and I think this might well be new to most of you. So these are the prime factors of 24. And so to make 24, we can use a 2 on its own, another 2 on its own, and 6, which is not what we did here. Okay, let me kill that calculator now. And I think we only need one alternative, so we'll just go with that one. And I wouldn't be surprised, you could have gone with 6. There aren't that many choices. The 3 is either on its own, and you have 2 2's together, or the 3 is with a 2. You can't have 8. Well, you could have 8 by 3 by 1, but it'd be a very long box, and that might be forbidden depending on how they how they put the question. So let's look again. There are a number of different ways of arranging the 24 cans so that they can be packed into a rectangular box. It may be different for different arrangements. Find the dimensions of the rectangular box required for a different arrangement. So I've devised a different arrangement here. If we look here, we had 4 by 3 by 2. So I'm going to go with 2 by 2 by 6. Now even then, there's choice as to where's the height. You know, the length and the width are the same because you're using the radius of the can, but the height is different. So let's stay with 6 high. Let's say with 2 high. Okay, we have 2 cans high. We have 2 cans deep instead of 3, and then we have 6 of them coming out this way. My drawing doesn't have to be brilliant, it just has to be for myself. It's 2 that way, it's 2 this way, and it's 6 this way. Okay, and then show your workings out, and do you see they make me then convert the height. So the height would still be 20 centimeters, but the length instead of being 4 times the diameter of 7.2 will be 6 times the diameter of 7.2. Okay, I can do that in my head, can I? I'll try and do it in my head. 6 7's 42, so I've got 6 by 7.2. 6 7's 42 plus 1.2, 43.2. And then the width is 2 7.2s, which is 14.4. Again, I want my centimeters here and my centimeters here, and show your workings out. What I did here, definitely, that's my workings out. Okay, that might have been a challenging question for you, but we'll be doing loads of number theory coming up to the exam because you need it for algebra, you need it for quadratics and factoring quadratics, especially when you factor quadratics manually, or that you don't go straight to the equation with the minus b formula with the quadratic equation. So it's all good. I hope I'm at the end of it. I double check, I am. A long video, but we got there in the end. As always, students, I'll see you in the next one.